There is a smell that takes you somewhere instantly. A song that pulls you back to a moment you haven't thought about in years. A face you haven't seen since childhood. And yet the moment you see it again, everything comes flooding back. The room, the light, the feeling. Your brain has been quietly holding that for decades. And yet you cannot remember what you did last Wednesday. You cannot remember the name of the person you met at that event 2 months ago, even though you shook their hand and smiled and said it was lovely to meet them. Memory feels random, unpredictable, almost cruel in what it chooses to keep and what it lets go. But it isn't random at all. In the next 10 minutes, you're going to discover why your brain forgets and why the answer is one of the most surprising things science has ever found about the human mind. Because forgetting, it turns out, is not what you think it is. In 1953, a 27-year-old man named Henry Molaison sat in a surgical chair and made a decision that would change neuroscience forever. Henry had suffered from catastrophic epilepsy since childhood, seizures so severe, so frequent, so consuming that his life had become almost impossible to live. His surgeon, William Beecher Scoville, proposed a radical solution. The seizures seemed to originate in a region deep inside the brain, a curved seahorse-shaped structure called the hippocampus. Remove it, and the seizures might stop. They did. But something else happened, something nobody predicted. Henry woke from surgery and could no longer form a single new memory. His childhood was intact, his personality unchanged. He could hold a conversation, follow a joke, smile at a nurse. But the moment that nurse left the room, she ceased to exist in his mind. Every day, the world reset. Imagine waking every morning into a life that has no yesterday. Every face a stranger, every room unfamiliar, every moment complete in itself, and then gone.
Henry Molaison, known to science only as HM for nearly 50 years, lived inside a permanent present tense until he died in 2008. His tragedy became one of the greatest gifts neuroscience ever received, because Henry proved for the first time that memory is not stored in one place. It is a system, distributed, layered, extraordinarily complex. And the hippocampus is not where memories live. It is where they are born. So what actually happens when a memory forms? Picture something almost impossible to imagine. Inside your skull, right now, 100 billion neurons are connected to each other through roughly 100 trillion individual links.
When you experience something, a sound, a touch, a moment, a specific constellation of neurons fires together. They activate in a precise sequence, creating a kind of electrical signature unique to that experience. Neuroscientists have a phrase for it. Neurons that fire together, wire together. The connection between those neurons strengthens with each activation. The memory becomes more durable, more accessible, more real. But here is what most people don't understand. Most of what you experience today will be gone by tomorrow. Not because something went wrong, because your brain is doing exactly what it was designed to do. Your brain processes roughly 11 million bits of sensory information every single second. If it tried to hold all of it, every face, every sound, every unremarkable Tuesday, it would drown. Forgetting is not the failure of memory. Forgetting is the mechanism that makes memory possible.
But what decides what stays? This is where something remarkable enters the story. When an experience carries emotional weight, real weight, the kind that touches fear or love or grief or wonder, your brain does something extraordinary. The neural connections involved in that experience are immediately strengthened, made more permanent, more resistant to decay. This is why you remember exactly where you were the moment you heard the worst news of your life, the quality of the light, the temperature of the room, what you were wearing. But you have no idea what you ate for breakfast on an ordinary morning 2 weeks ago. Your brain doesn't record life like a camera. It records what it was told by your own emotions to care about. And everything else, it lets go.
There is a particular kind of forgetting that is not forgetting at all. You meet someone, you hear their name, you even repeat it, and by the time you turn to find a seat, it's gone. For years, scientists called this a memory failure. It isn't. Now the story reaches the moment that changes everything. Because here is what science discovered, and what almost no one outside the research world fully understands. You do not remember the past. You reconstruct it. Every time you recall a memory, your brain does not open a file and play it back the way a video plays on a screen. It rebuilds the memory from fragments. It pulls pieces together, some accurate, some estimated, some quietly borrowed from everything you've experienced since that original moment. And each time it rebuilds, it changes. Psychologist Elizabeth Loftus spent decades proving this in ways that are still difficult to accept. Half were asked, how fast were the cars going when they smashed into each other? Half were asked, how fast were the cars going when they contacted each other? One word different. One word. The smashed group estimated significantly higher speeds, and 1 week later, they were substantially more likely to remember seeing broken glass scattered across the road, glass that did not exist anywhere in the footage. A single word embedded in a question changed what people were certain they had seen with their own eyes. Neuroscientist Kareem Nader at McGill University discovered the biological mechanism behind this in 2000. Every time a memory is recalled, it enters a brief window of instability, a period during which it can be rewritten. This is why eyewitness testimony, for over a century considered the most powerful form of evidence in a courtroom, has been shown again and again to be dangerously unreliable. More than 300 people in the United States alone have been exonerated after wrongful convictions. In more than 70% of those cases, false eyewitness memory was a central factor. Real people, absolute certainty, completely wrong. Not because they lied, because they remembered. And now, the twist that changes how you see all of it.
In 2007, neurobiologist Paul Franklin at the Hospital for Sick Children in Toronto. The brain, Franklin found, is constantly growing new neurons in the hippocampus, even in adulthood. And this growth, this new life, disrupts the memories already stored there. The brain doesn't just passively allow memories to fade, it actively clears them, to make room, to stay flexible, to keep learning. Babies and young children, whose hippocampi are generating new neurons at an extraordinary, almost explosive rate, retain almost nothing from their earliest years. Most adults have no memories from before the age of 3 or 4. Not because nothing happened during those years, because the brain was growing so fast it couldn't hold what it was recording. Childhood amnesia is not a malfunction. It is a sign of how ferociously a young brain is building itself. And this means something profound. The brain that forgets most easily is the brain that is growing most powerfully. Forgetting is not the enemy of learning. It is the condition that makes learning possible. Tonight, while you sleep, your brain will do something you will never feel happening. It will sort through every experience from today. It will strengthen what carries emotional weight and quietly release the rest. You will wake tomorrow having forgotten most of today. And that is not a loss. That is your brain doing its most essential work. But here is the question worth sitting with. If every memory you hold has been reconstructed,
and each reconstruction has changed it? If the brain that forgets most is also the brain that grows most, then the story you tell about yourself, who you are, what you've been through, what made you, is not a record. It is a living document, one your brain has been quietly editing, revising, and rewriting every single day of your life.
The question is what version of yourself your brain has been building with the pieces it chose to keep. You are not who you remember. You are who your brain decided to remember you as. Tonight, your brain will do something remarkable while you sleep. It will choose what to keep and quietly let the rest go. If you're curious about how your mind and our world really works, subscribe to Why Decoded, because everything has a reason. We just haven't decoded all of them yet.